Hello. In this presentation, I'll cover the work we've done over the last few months towards the development of a log-end biometric system. York Timbers is a solid wood processor. It currently uses a barcode system to track its logs from plantation to processing plant. The company wishes to reduce costs by implementing a biometric system. The primary objective of this project, therefore, is to evaluate the feasibility of developing a log-end biometric identification system using machine learning-based computer vision models. The project will also aim to determine whether it is possible to identify features such as the Pith mark. 348 images are provided for this task. For image segmentation, we utilized we utilize a convolutional neural network based on the UNet model architecture. The UNet model architecture was developed by universities at the University of Freiburg for biomedical image segmentation, as shown below. To achieve the scars, we manually annotated 156 images, as shown on the right. To then increase the amount of examples we have for training as well as validation, we applied augmentation by rotating the image and along with its mask 3 times by 90 degrees. This gave us 524 training images as well as 100 images for the validation set. The results of training 5 models using a different seed number to perform the training validation split is shown here. As you can see, all trained models predict 97 to 98% of correctly predict a class of 97 to 98% of the pixels. Shown here are the outputs on three examples. You can see the model is quite adept at following the contours of even irregularly shaped logends. After segmentation has been performed, we also need to develop a model which can identify two segmented images belonging to the log end, to the same log end, as well as 2 images that do not belong to the same log end. For this purpose, we employed a Siamese network, which is a network consisting of 2 identical subnetworks, which have the exact same weights and biases. Each subnetwork reduces an image to an image embedding, and you calculate the distance between those embeddings using some distance function, and then the resultant tensor is sent to a neuron with a sigmoid activation function, which predicts the match probability. 300 of our 348 images are used to train, validate, and test the Siamese network. Each image is paired with its augmented self 42 times, as well as with some randomly chosen other image 42 times for a balanced class distribution. As for the number of pairs available for each dataset as shown. Again, here we ran the model multiple times, 5 times, using a different seed number to perform the training validation split. And we see that it had a classification accuracy of around 87% on the test, of 86% on the test dataset. And these are some of the outputs from the Siamese network. If you were to say use a prediction threshold of 60%, as we found is the most accurate, one of these would have been classified as a non-match, since it has a 58% probability of being a match. Lastly, for the Pith detection model, we used the YOLO model, the you only look once model architecture, which was developed for object detection. We modified it to predict a single point. 131 images were manually annotated, and through augmentation again, rotation, and horizontal and vertical flipping, we increased the number of training and validation examples as shown. We found that the predicted pith mark location is on average a distance of approximately 15 pixels away from the ground truth, as shown here. This loss curve is shown for a mean absolute error loss. And the outputs, the red dot indicates the ground truth, which we manually annotated, and the blue dot is the prediction. Moving forward, we obviously need to increase the size of our data set in order to produce more robust models as well. And also, we were not able to account for variation for temporal changes in the log end, since we only had a single photo of each log end. So we are not able to see what kind of color or texture changes may occur over time. Thank you.